The enum module has all sorts of helpful functions. Here's a list of all of them, but I'll let you in on a secret. There's one function in this list that's more powerful than all the others. Let me explain. Most of these functions do specific things. For example, the map function transforms the elements in an enumerable from one thing to another. The filter function can remove elements from an enumerable. And if you look at the names of the rest of these functions, you can pretty much figure out the specific thing each of these functions do. Now, whereas most of these functions do specific things, one of these functions can do pretty much anything. Which function am I talking about? The reduce function. Now, just to be absolutely clear in what I'm saying, every single one of these functions could be replaced by the reduce function. So you might be wondering, why are there all these functions if we could just use reduce instead? Well, the reason, in my opinion, is because each of these specific functions are easier to use, and more importantly, easier to read, versus just using the reduce function. Here's what I mean. If you're reading some code and you see the map function, you largely know what's happening before you even dig into the details. And using map is relatively simple. You just pass it an enumerable in a function, and you get an enumerable back. Now, for discussion's sake, let's say you need to do something where map would work, but you didn't want to use the map function for whatever reason, and you instead use the reduce function, which is totally doable. Then at a later point in time, I come along and I look at your code, and I see the reduce function. Now, at a glance, I don't really know what your code is doing, because it could be doing anything. So I've got to dig a bit deeper to understand what the code is doing. So hopefully that gives you a sense of why there's all these specific functions that are generally preferable to using the reduce function when possible. But sometimes, reduce is the only option, so let's take a look at the reduce function. I'll step you through a simple example of the reduce function to start. Let's say we've got a list of 4 integers, and we'd like to add each of these numbers together. One way of handling this would be to call the enum module's reduce function, passing in the data to act on first, and then passing in a function as the second parameter. This function parameter you use in the reduce function is sometimes called the stepper function or a reducer. The reducer has an arity of 2. I'll name the first parameter in, and the second parameter I'll call ACC, which is short for accumulator. Now the reduce function will grab the first element of the list and pass it into the reducer function as the accumulator. Then it'll grab the next element from the list, and it gets passed in as the in parameter. Next, the reducer adds these 2 parameters together, and it returns the result. So what happens to the return value from this function? Well, hold that thought. You'll see in just a moment. Next, the reduce function gets called again with the next element of the list, the 3, and it's passed into the reducer as the first parameter, and the return value from the last call of the reducer function gets passed into the reducer function as the accumulated value. Now the reduce function moves on to the next number, the 4, and the return value from the previous reducer function call gets passed in as the accumulator. At this point, there's no more values in the list, so the return value of this last reducer function call gets returned by the reduce function. I want to go on a small tangent for a moment just to point out some different options to this solution. I'll copy and paste this line, and I'll rewrite the reducer function to use the capture operator syntax that I introduced in the last video. So to do this, I'll key in the capture operator, the ampersand, then in parentheses, I'll key &1, which is the placeholder for the first argument, then I'll add it to the &2, the placeholder for the second argument. Okay, this new anonymous function does the same thing as this anonymous function, it's just an alternative syntax. Let's try it out. And it works. Cool. So which one of these options is better? Well, that's really a subjective thing, but personally, I like this one. It's easier to read. Let me show you one other alternative solution. I'll copy this line again, and I'll rewrite the reducer function. But before I do, I want to draw your attention to something. The plus operator that's used right here and right here is really just a function, an infix function, so we could use the capture operator for the plus function, which is a named function with an arity of 2. Let's try this code out. And it works as well. Cool. Okay, let's get back to the reduce function. This reduce function that we used has an arity of 2. It takes the enumerable and the stepper function, but there's another reduce function that has an arity of 3. Any thoughts on what the third parameter might be used for? Well, this function allows you to pass in a starting accumulator value as the middle parameter. So let's add a middle parameter, and I'll set the value to be 100. So how does this work? Well, when the reduce function runs, it starts by grabbing the first element of the list, the 1, and it gets passed in as the first argument here, and the 100 gets passed in as the second argument, the accumulated value here. Then the return value of this function, 101, is passed into the second call of the reducer, along with the second element of the list, and this pattern keeps repeating until the last number is pulled from the list, and the final accumulated value is returned by the reducer function. Now here's a key point to recognize. In my example, we only dealt with numbers, but this list could have any data type in it, and the accumulated value doesn't have to be a number. It could be a list, a map, a tuple, or any data type. Now, should we have used the reduce function for adding these numbers together? I'd say probably not, because we could have just used the enum module's sum function, which is easier to understand at a glance, at least in my opinion. In the next video, we'll take a closer look at combining the functions in the enum module using the pipe operator, and we'll consider some of the potential downsides of using the pipe operator with the enum module.